Good evening, class. This video is going to be about naming binary compounds of two nonmetals. Crucial aspect of this lesson is going to be understanding the prefixes that are on page 137 in table 5.3. You can find that in your textbook. We've added two, which are number 9 and number 10. Nona and Deca are not in your textbook, so make a note of that. Notice that in these prefixes, we're using di for two, not bi. Again, that's di for two, di. And for four, we're using tetra instead of quad. Again, that's tetra. So beware of this as you're using these prefixes to name your compounds. All right, now that we have those prefixes out and memorized, we're going to go straight into some examples. The first we're going to start with is N2O5. We're going to name this. The name of this formula is dinitrogen pentoxide. Now we see that this di came from the 2 behind that nitrogen, that N right there, and the pent in the oxide came from the 5 behind that O right over here. We also notice that there's a different suffix at the end of this compound's name. Now this "ide" is similar to the ionic compounds that we did earlier in an earlier video, and this naming system is seen on the bottom of your oxidation number sheet, the bottom left-hand corner. And like I said, it's the same system we use with ionic. So the "ide" is added to the end of the second element in your compound. All right, so now we're going to work on one more example. It's going to be P4O6. So the name of this compound is tetraphosphorus hexaoxide. And we see again that this tetra came from this 4 underneath that P. The hexa came from the 6 underneath that O. And we added that suffix "ide" to the end there of that second ion. As all things in chemistry, we find that there are some exceptions to these examples, so we're going to go over those right now. The first is going to be with CO2. Now written out, that should look like this if we follow the rules. Monocarbon dioxide. As I said, there's an exception in this particular compound, and that is that this mono is not written at the front of the first ion. This exception is only true for the prefix mono, including the first element. And as you can see, we still keep the di for the dioxide. We just cross off the mono for the monocarbon. And so now this becomes carbon dioxide. Let's look at this same example of an exception with CO. So how this should look is monocarbon monoxide. As we stated earlier, an exception to this is that the first prefix for carbon, only for mono, is not stated, but the second prefix stays. So rewritten, this will look like carbon monoxide. All right, so now what we're going to do is go backwards from the name to the formula before we're going formula to name. So we're going to start with dinitrogen dioxide. So because we have the di and nitrogen, it's going to look like this. Because we have the di and oxide, which means 2, we're going to have oxygen, which is oxide, and the 2 there. All right, so our next example is going to be diboron trioxide. So again, remember that di means 2, and boron is a B, and then tri means 3. So we're going to have an oxygen, O, and 3 underneath. All right, our next example is going to be silicone dioxide. And this may seem weird because there's no prefix for the silicone. But remember that earlier, when we worked with carbon dioxide, there should have been a prefix for that mono, but we didn't put it because mono, the prefix, is not shown. Chemists are lazy, remember that. So this will look like, that should be mono silicone, but we don't add the mono in, so we'll do Si. There's 2 di-oxygens, so we'll have an oxygen with 2 underneath. All right, our last example is going to be nitrogen monoxide. Now remember that nitrogen, even though it doesn't have a prefix, if there's no prefix for that, you assume that it's mono. So this is going to be N for nitrogen. And then we have the mono oxide, which means 1. So that oxygen, and you don't need to put anything underneath. And that's it. Thank you for listening. So one point of emphasis I want to point out to you guys is that we did ionics in the previous lecture or video. And remember we used our little scale as a reminder of balancing out the equations. Now today we worked on binary compounds, which are also called molecular compounds. And instead of using that scale, what we did is for these binary compounds, or molecular is another name we'll use for them. Remember, we use prefixes. So I want you to keep in mind as you're working on worksheets in class and on tests and quizzes that when you're using ionics, you're using the scale to balance out those formulas. And when you're working with binary or molecular, which are 2 non-metals, you're going to use prefixes.